Today we're going to be discussing projectile motion. The goal of our lab was to observe how drag force affects the projectile motion of an object. We had two coded models in our lab. We had a coded model with gravity and a coded model with gravity and drag force. Some physics fundamentals for this lab to understand is the momentum principle, which states if a net force is applied to an object, its momentum will change accordingly. And there are three equations to understand: the position update formula, the velocity update formula, and the drag force formula. This will be shown later on. And here are the results of our lab. Our predicted results is that drag force negatively affects the projectile motion of an object. And we were correct, because as you see, the light green curve in this graph is the model with strictly gravity. And the other two that correlate with one another is our experimental data and our model with gravity and drag force. As you see, we do have some slight deviation in the curves, because that is either human error in the code or during the experiment. Our experiment, we threw a paper ball in a strictly XY coordinate plane and then videoed that and then put it in a tracker to obtain our data. And we compared it in Excel. Here is the video.
Good, but okay.
Good?
Yep. Good, but okay.
We replicated that data using GlowScript, which makes it very easy to replicate the experiment. We put in the mass of the paper ball and the initial conditions of the ball, which was the initial position and the initial velocity. We then put in the gravity, and we put in, as you can see, B equals 0 for this experiment because we are not using drag force. In our time loop, we have F net is strictly gravity, and then we have the position update formula and the velocity update formula, which was why it was very important at the start. And that is the position update formula and the velocity update formula in the bottom left-hand corner. The code below that makes the models that we will show later on. And what we did differently for the drag force model is that we changed B now equals 0.2 because that is a drag force coefficient. And then we calculated drag force in our time loop and then added that to our F net. And that is the drag force formula in the bottom left-hand corner. Here is the data it gave us. As you can see, the one on the top is the one with drag force, and it does not go as far as the one with gravity. We might have made slight errors in calculating the drag force and might have made it too much, as you can say, but it would still be less than the one with gravity as it goes much further. Here are the models it produced. As you can see, the one with gravity has a much further trajectory than the one with drag force, which is in the bottom left-hand corner. And the arrows that you see is the velocity, which is pink, and the gravity, which is blue. We did have some slight errors with the arrow for drag force. The system is the paper ball itself, while the surroundings is Earth and the atmosphere. Some what ifs. What if we threw the ball strictly vertical instead of at an angle horizontally like we did? What would happen? How much time would it take for it to arrive back at its initial position? And I believe it would take the same amount of time because we still go the same height and it would return in the same time it would take if we threw it like we did in our experiment. And our what does it mean question asks, do we experience terminal velocity, which means have an F net of 0, meaning constant velocity. We have constant velocity. Our top two graphs is our gravity only model, which shows we have constant velocity in the X, but not in the Y, because we have gravity affecting the Y coordinate. Now you can see we almost have a plateau in our XY velocity for our drag force model, but we do not experience terminal velocity. To have an experiment that does have terminal velocity, you should drop an object in a fluid and then measure the velocity over time. We performed this experiment to measure how drag force affects the projectile motion of an object. The results were that it negatively affects projectile motion, and it makes the distance much less than it would with just gravity. We did have some slight errors in our code, but that is not much. Thank you for today. Thank you for watching. Have a good day.